Another useful technique of finding the square roots of numbers is by the use of prime factorization technique that we learned previously when we were discussing the factors and multiples. But this is typically helpful more for smaller numbers. So why don't we just look at some examples to understand what is prime factorization and how we are going to use it to find the square roots, okay? So I'll take a very simple number first, 64, okay? In prime factorization, I take 2, I divide 64 with 2 because 2 is the lowest prime number, correct? And I get 32. Then I divide 32 again with a prime number which is 2 again, right? And then I get 16. 16 can be further divided, becomes 8. Further divided becomes 4. Further divided becomes 2, and then we get finally 2. And that's where we can stop because you cannot divide it any further from here on, okay? So these are all of these 2's that we have collected here. These are our prime factors, correct? If you were to write down, this becomes 2 to the power 1, 2, 3, 4, 5, 6, 2 to the power 6. So 64 can be written as 2 to the power 6, correct? Now when you have to find the square root of 64 means 64 to the power 1/2, right? We can write it this way. So which means 2 to the power 6 to the power 1/2, right? Now what happens when you have a power to the power and you can multiply the powers and the base remains same, right? So this becomes 2 to the power 6 times 1/2, which is 2 to the power 3. Or in other words, this is your answer. Meaning the square root of 64 is equal to 2 cube, or you can write this as 8. And we know that 8 square is 64, right? Now in this case it was a simple number, but let's take one more example. In this one I'm taking a slightly longer number, okay? And that number happens to be, let's say, 225, okay? So with the prime factorization technique, I'll first divide with the lowest number that I can find, which is a prime number, and so 225 clearly is not divisible by 2, correct? Then I go to the next prime number, 3, and 3 divides 225, it becomes 3 times 7 is 21, and then 5 here, okay? 75, it is divisible by 3 again, so I get 25, and 25 becomes 5, and that's where we can stop. So our prime factors are 3, and then 5, and another 5. This is how you write down 225 as a product of these prime numbers, right? And when you square root 225, you're basically putting a square root on all of these numbers, okay? Or in other words, you're saying that it is equivalent to writing square root of 3 square times 5 square, because there are 2 3's and there are 2 5's, right? There's nothing wrong in writing this statement. And this square root basically goes on each number because they both are in multiplication, right? And this can be written as 3 times 5 or 15. In other words, square root of 225 is 15. So this is another technique, that how do you find the square root of numbers, the perfect squares, using the prime factorization, okay? But this method typically is best suited when you don't have a very large number to deal with, okay? Otherwise, it will take you really long time to get all of these prime factors. So we'll pause here for this method, and then we will go discuss our next method of finding the square root, which is a long division method, the typical method that you will read in books.